Good day, learners. I am Mr. Melvin Kiboy Ogsaimer, your presenter. I am here to discuss our topic about the understanding of an electricity. So, electricity is a fundamental concept that permeates our daily lives, powering everything from households, appliances, to transportation. This lesson aims to introduce students to the basics of electricity, focusing on its principles, components, and real-world applications. And our learning objectives, by the end of this lesson, students will be able to define electricity and explain its basic properties, describe the flow of electrons and differentiate between static and current electricity, identify conductors and insulators and their roles in electrical system, understand the basic circuit concepts including series and parallel circuits. Introduction to electricity. Start with the class discussions about the importance of electricity in daily life. Ask questions like, what would your day look like without electricity? Can you name some devices that rely on electricity? Electricity is a fundamental concept in physics and engineering, encompassing the movement of electric charges and their interactions. This presentation will cover the basic of electricity, including its definitions, components, and principles. What is an electricity? Electricity, it is a fundamental form of energy resulting from presence and movement of electric charges, primarily electrons. It can be defined as a flow of electrons charged through a conductor, which is essential for powering various devices and systems in modern life. Electricity, it refers to the flow of electric charge, primarily carried by electrons and conductive materials. It is a secondary energy source derived from primary sources like fossil fuels, solar energy, and nuclear power. Electricity is a fundamental aspect of physics and engineering, involving the movement of electric charges and their interactions. This overview will address key concepts, components, and principles related to electricity. Electricity is the phenomenon associated with stationary or moving electric charges. The primary charge carries in electricity are electrons, which carry a negative charge. The behavior of electric charge results in various electrical phenomena, including electrostatic and current flow. Electricity encompasses both static and dynamic phenomena. This movement can be categorized into two primary forms: static and current electricity. Static electricity, this refers to the accumulation of electric charge on a surface, which can occur when two different materials are rubbed together, causing electrons to transfer from one material to another. This results in one object becoming positively charged and the other is negatively charged. Current electricity, this is the flow of electric charge through a conductor, typically in a closed circuit. Current electricity powers most of our electronics devices and appliances. How electricity works. The movement of electricity involves several key concepts. Electric charge. The electric charge is property of matter carried by particles such as electrons, which have negative charge, and protons, which have positive charge. The interaction between these charges gives rise to electric fields and forces. Electric current. When electrons move through a conductor, like copper wire, they create an electric current. This flow is driven voltage which act like pressure pushing the electrons through the current. The voltage, measured in volts, voltage represents the potential difference that pushes electron charge through a circuit. Higher voltage means more potential energy for the electrons to flow. And for historical context, Benjamin Franklin, who demonstrated that lightning is a form of electricity. This kite experiment in 1752, Franklin famously conducted his kite experiment during a thunderstorm by flying a kite with a metal key attached to the string. He demonstrated that lightning is a form of electricity. This experiment provided crucial evidence of the electrical nature of lightning and led to the invention of lightning rod, which protects buildings from lightning strike by directing electrical charges safely into the ground. Thomas Edison, known for inventing the incandescent light bulb. The incandescent light bulb, while Edison did not invent the light bulb, he significantly improved upon existing designs. His successful development of a practical incandescent lamp involved creating a vacuum inside the bulb and using carbon filaments that could last over 1,200 hours. He patented these designs on January 27, 1880, which made electrical lighting commercially viable and accessible to the public. Nikola Tesla, who developed alternating current for efficiency electricity transmission over long distances. Nikola Tesla was a groundbreaking inventor and electrical engineer who contributes to electricity fundamentally transform the field and modern societies. His work primarily focused on alternating current or AC systems, which become the standards for electrical power and distributions. Conductors are materials that allow electricity to flow through them easily due to the presence of free electrons. These electrons can move freely from atom to atom, facilitating the transfer of electrical charge. The characteristic of conductors is highly electron mobility. Conductors have a large number of free electrons that enable easily to flow of electricity. Example, common conductors include materials such as copper, aluminum, silver, gold. These materials are often used in electrical wiring and components due to their efficiency in conducting electricity. The roles of conductors in electrical system is the power transmission. Conductors are used to create electrical circuits that transmit power from generation source like power plants to home and businesses. The component of connections, they connect various components within devices, ensuring that electricity flows where needed for operations. Insulators or non-conductors are materials that resist the flow of electrical charge. These electrons are tightly bound to their atoms, making it difficult for them to move freely. The characteristic of insulators it is a low electrons mobility. Insulators have very few free electrons, which accounts for their ability to impede electrical flow. Examples: common insulators include rubber, glass, plastic, wood, and dry air. These materials are crucial for preventing unwanted electrical currents. The roles of electrical system for safety insulators protect users from electric shocks by preventing unintended contact with the live wires. For example, the rubber coating on the electrical wires prevents accidental exposures to the conductive metal insides. The circuit's integrity they ensures that electricity flows along intended paths without leakage or short circuits, maintaining the integrity of electrical systems. What is an electric circuit? An electric circuit is a closed loop that allows electric current to flow through a path made up of various components. These components typically include power source, conductors, load, and switches. Electric circuits can be classified into two main types: series circuits and parallel circuits. In series circuit, all components are connected end to end in a single path for current to flow. The key characteristics include same current, voltage divisions, total resistance. The same current of amount flows through each components because there are only one path for the electrons to travel. For the voltage divisions, the total voltage from the power source is divided among the components. The voltage drop across each component depends on its resistance. The total resistance is in a series circuit is equal to the sum of the individual resistance. In parallel circuit, components are connected across common points or junctions, creating multiple paths for current to flow. The key characteristics include same current, voltage divisions, total resistance. The difference currents, total current entering a junction splits among the parallel branches allow different amounts of current to flow through each path. All components share the same voltage as the voltage power source. The total resistance in the parallel circuits can be calculated using the formula. Understanding the series and parallel circuits is crucial for designing and troubleshooting electrical systems. Series circuits are simpler but less reliable due to single path nature, while parallel circuits provide greater reliable and flexible by allowing multiple paths for current to flow. These concepts form the foundation for more complex electrical engineering applications.